Okay, the next topic is can matter change its state? Now, we all know that water can exist in uh, three forms, right? Solid, liquid, and gas. Now, how do we change um, it from solid to liquid, from liquid to gas, and vice versa? Now, what we can do here is we can do two things. Maybe we can either change the temperature, change the temperature, or we can change the pressure. Okay. Now, effect of change of temperature. What is the effect of increasing the temperature of ice? Right. That is changing from solid to liquid. Okay. Now, so suppose that we are applying heat, supplying heat. Okay. So when we supply heat to the ice, okay, this heat energy will be absorbed by the particles and then it will be converted into kinetic energy. Okay, be converted into kinetic energy. So they will start to vibrate, okay, about their mean position. They will start to vibrate about their mean position, and once it reaches 0 degrees Celsius, which is their melting point, it will start melting, okay, and then change into liquid form, right? That is what happens. Now in liquid form we have spaces, right? So uh, just visualize it as it is in the picture. Okay, now latent heat of fusion. So to understand this, okay, we need to know what happens when ice is heated, right? Now we all know that when ice is heated, it changes to um, liquid state, right? From it changes from solid to liquid state. That keep in mind. Also keep in mind that when there is change of state taking place, okay, then there is no change in temperature. This is in your textbook, the page number 7, okay, the last paragraph. Now, if you read, you must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached. Okay, till all the ice is till all the ice melts, right? So that is what you need to keep in mind here. Now uh, consider the graph. Okay, now let's say you are heating the ice, so the temperature will increase, and then it will stop. Okay, now let's say the initial temperature was minus 10 degrees centigrade, well below the melting point of ice. So at this temperature, the ice is um, pure solid. Okay, now you keep on heating for 1 minute. Okay, you keep on heating for 1 minute, and then let's say the temperature at which it stops rising is, let's say, the melting point of ice, which is um, 0 degrees Celsius. So it will start to um, go flat for some time, even if you keep on heating. Okay, so it is going flat. Then as you after some time again, it goes up. Okay, the temperature rises up again. Now here, um, just a moment ago, I told you that during um, change of state, there's no change in temperature, right? So here in this case, see, at this is the level at which it is. This is the level of 0 degrees Celsius, which is the melting point of ice. So here, at this flat line represents your change of state. Okay, the change of state. Right now, um, here, since you have the change of state here, you will have both solid and liquid at the same temperature, that is 0 degrees Celsius, right? Okay, because let's say, for example, we have reached till here. Okay, so let's say this is the second minute. Okay, this is the third minute, this is the fourth minute, this is the fifth minute. No, this is the second, third, fourth. Okay, 1, 2, 3, 4. Now let's say we have reached the second minute. So in the second minute, definitely some of the uh, ice should have turned into water, right? And then at that same temperature, um, there will be some um, still in the process of melting the solid, right? So there is solid and liquid at the same temperature, right? So now here, there's a question, okay, in which state uh, will the particles have more energy at the same temperature, right? Now here for that, if you consider solid and liquid, in solids you have particles that are tightly packed, right? Yeah, tightly packed. So there is no scope of motion. Okay, so there is no scope of motion. So no motion means no kinetic energy. In case of liquid, you have spaces between them, right? So there is scope of motion. So if there is motion, there is kinetic energy. So your answer will be the particles in the liquid state will have more energy than the particles in the solid state at the same temperature. All right. Now come back to the graph. Um, see, in the first minute, okay, in the first minute, in this time frame, um, the temperature is rising up, okay, from minus 10 degrees centigrade to 0 degrees Celsius. Now, what actually is happening here is the heat energy, okay, from the burner is being absorbed by the particles, and this energy is converted into kinetic energy. So kinetic energy is increasing, okay, this increasing, and as you keep on heating it, it stops increasing and then it goes flat. Now if you are increasing, no, if you are supplying the heat continuously but still the energy is not the temperature is not going up, right? That means the uh, the energy is going somewhere which is not being observed. Okay, now if the energy that is supplied during this time period of the flat line, okay, then, no, what am I saying, if um, the energy that is supplied during the time frame of the flat line is uh, used up here, okay, then definitely the rise, the mercury in the thermometer will rise, but it is not rising up. Okay, so the question is, where is that energy going, right? Where is that energy going? Now that energy is being absorbed by the particles, okay, that energy is being absorbed by the particles to overcome the forces of the intermolecular forces of attraction. Okay, so that energy that is used to overcome the intermolecular forces of attraction is called the latent heat. Now latent heat means hidden heat, right? Latent means hidden. Now, why do we say it is hidden? Because see, here in the flat line, in the time period of the flat line, the energy is still being supplied, right? But the temperature is not rising up. Okay, so it is not that supply of energy is not being observed in the thermometer. So we say that in a way that it is hidden. Okay, so it's just that that heat is used up by these particles. Okay, these particles to overcome the intermolecular forces of attraction and change its state into liquid form, right? So I hope you are clear with the concept. The exact definition of latent heat is in your textbook. It is defined as the amount of heat required to change 1 kg of solid into liquid state at 1 atmospheric pressure. Okay.